kind of like not able to talk.
No, you're good.
Thanks.
Okay. So question 3, when you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
I wasn't super clear on this one, on like the whole shape thing. So I didn't see too much in the reading about figuring it out. I could have just missed it. But does anyone have a good idea of what's going on here?
I'm trying to find in the reading I played around with that little.
Oh, the little sampling.
Yeah, the little sampling thing.
Yeah.
So I was going to look at that because I think that's.
So
So n equals 5, and then
isn't it normal?
I think normal is what I'm seeing on the thingy.
Yeah.
Okay.
Okay, question 4. When you're taking a sample size of n of 100, what is the shape of the distribution of mean histogram when the population is skewed or is right skewed?
So
Okay. Because the higher the sample size, the more it's going to reflect the actual data, right?
Yeah, I thought it was more normal if it was larger.
Okay.
I don't know if that's right or not.
I'm going to be honest, I don't really understand how this thing works.
Yeah. That's okay. We'll get through the quiz we best. I can English. We'll get through the quiz the best we can, and then I'll just submit it and see how we did, and we can go from there.
Okay.
When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
Let's find out.
Okay.
Man, this animation is slow. It looks like left skewed is what the animation is showing me.
So how do you change the like n? Can you even change it?
Yeah, it's down below in the third graph.
But it only goes to 25.
Yeah.
Yeah, so we can't check against it for like n equals 100, but for the 5 through 25, we can kind of get a good idea of how it's working.
So where are you getting it? It's left skewed. And
so I'm looking at, let's see. I am looking at. Oh, I have to clear. That's why it's not doing it.
The clear, yeah.
Yeah, this is terrible. I really want to rewrite this, honestly.
I know.
But anyways, when I do the n equals 5 and I'm looking for the mean in the third graph, I changed the distribution to normal, and it's more on the left side.
Okay.
So, like, I'll screen share real quick and show you. Application window. Okay.
Isn't it random?
Isn't what random?
Like
It is random.
Like
Yeah.
if you clicked on animated again, it would get a different result.
It does. I just did it twice
Yeah,
on.
Oh, yep.
Something else.
You do.
Oh, right. That's that. Oh my gosh, that's super helpful.
Oh no.
So then you can do like the 10,000, and it will show.
Yeah.
I thought it was normal. If it's normally distributed.
It's just continually moving to the right. Oh, that's bad. Okay. Well, never mind then. I'll stop screen sharing. That's awesome.
So I'm not sure. Okay, the histogram when the parent population is skewed right. Isn't this the histogram that they're talking about?
Yeah. Okay. If you look closely, you can see that the sampling distributions do have a slight positive skew. The larger the sample size, the closer the sampling distribution of the mean would be to a normal distribution. Okay. Well, who's good at guessing?
I think we'll just guess.
Oh, here on the where it says exercises,
Uh-huh.
you kind of get a explanation of how it actually works. And it says on number 2, it says click the 5 samples button to sample 5 samples of 5 scores each. Plotted. Click the 500 samples and or 2,000 samples until the distribution of the means has stabilized. Sampling distribution of the mean in the distribution that is approached as the number of samples approaches infinity. Oh, great. So that's not helpful.
Nope. Oh, this is great. Okay. Approaches infinity. So everything is right skewed, I guess.
Oh. Are you putting right skewed right, Ben?
No, not for everything. I'm just okay. When you're taking a sample size of 100, normal. I'm gonna guess normal.
I think normal, but I think the
Percent.
first two are different. I don't think that they're normal,
Why
are
does
they?
it give us the normal probability applet at the beginning of the quiz? Like,
Yeah.
how is that cool?
Why would it give us that when we're looking at distribution of means histogram?
I don't know. I'm wondering if it's just a static link they throw into everything, because it said if needed, here's a link to the normal probability app.
Yeah.
That actually makes sense.
So I guess they couldn't use individually. I don't know.
Okay. I am gonna put normal on 5 and 6.
Okay, that works for
7.
me.
7. What would the distribution means be normally distributed? Data are drawn from population that is normal distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large. Data are drawn from a population that is right skewed and the sample size is small. Data are drawn from a population that is right skewed and the sample size is large.
Okay. I'm thinking the data are drawn from a population that's normally distributed and the sample size is large is probably a safe answer.
Yep.
All right, according to the reading, it says, when is it normal? If the parent population is normal, the sampling distribution will always be normally distributed, no matter how many observations are selected. If the parent population is not normal, then the sampling distribution will be approximately normal distributed if the sample size is large enough.
So I would say it is data that is normally distributed. The sample size is small. Normally distributed sample size is large, and then data drawn
Probably.
from a population.
I
Right.
agree with that.
Yeah.
That kind of leads me to believe that everything for 3 and 4, or I'm sorry, 5 and 6, I would say that it makes it normal.
Normal.
Uh-huh.
Or normal.
For
4 is
4,
probably
I'd say
normal.
it's normal, and
And then-
5, it could be any of them.
3 is question 3. Would that mean it's skewed right?
Hold on. If it's skewed, it will require a larger sample size. It doesn't say. For skewed distributions, sample sizes means it's normal. I don't know how to.
Yeah, I'm gonna guess skewed right on number 3,
Yeah,
Okay.
just because odds are you're gonna land kind of.
33% chance.
Yep.
Okay,
You're
which
probably gonna land in the skewed direction of the sample size of the actual samples. So
okay, so question 8, which of the following gives the best explanation of the central limit theorem? Okay, where's my
let's see. It's not 2 because that was the other one.
All right. In other words, the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. This result is called the central limit theorem. So basically, it's saying if the sample size is large enough, then the sample mean
sample
will
mean
be.
X will be
normal.
close.
Yeah. So it would be the last option.
Yes,
Number 4.
I think so. Let me read the other 3 really quick.
So if sample size is large, the shape of the
I
distribution
would
of the
say
sample.
that's a safe bet.
Yeah.
Fingers crossed.
Let X
Let
be a
X-
random variable.
Be a random variable with a population mean of 10 and the population standard deviation of 6. Suppose a sample size n equals 36 drawn from this population. What is the mean of the distribution of sample means? This is our formula. For a as a mean of u and the standard deviation over square root of n.
That's the standard deviation of the distribution of sample means. That's question 10.
Is that number 10?
It's just asking for the mean of the distribution of sample means. I don't really understand what the difference is.
Isn't it 10?
I think so.
Is it 10? Is that what you guys think? Is 10?
I think so.
It could be, but the wording is making me kind of doubt it.
Or is it reading?
Which one are you on? Number 10 or number
Oh,
9?
wait. Okay.
The
Right
mean
here. Yeah, it's
of the sample mean is the population mean.
it's
Alright.
in the solution for the first question in number 4. I forget what that's called. The U shape.
The mean. I think that's the
Yeah,
Mean.
it is the mean. So it's the mean of
The population mean.
yeah.
So it's 10.
Yeah.
What is
That's
the
what
10?
the solution is saying.
what is the standard deviation of the distribution of sample means? So this would be the standard deviation over the square root of the population.
Which
So
would be
it's 6 over the square root of 36, which is 6. Would it be 1?
that makes sense to me.
Regardless of the distribution of population, if the sample size is large and is greater than 30, what would the shape of distribution of the
I'd say
distribution?
that's normal,
Normal.
Probably normal.
according to the central limit theorem.
Yeah.
Okay, who wants to try it?
I will. I don't care.
What are we saying? The last one is the central limit theorem.
Central limit theorem.
Okay.
I'm going to go ahead and submit it. I just did. So number 3 is wrong. Everything else is right.
Okay. And what did you put for 3?
I put normal, so it's probably skewed right.
Okay, I'll go ahead and submit. I have it set to skewed right.
Watch it be skewed left.
I know, right?
I don't see how it could be. I didn't see that anywhere in the reading.
Yeah, I didn't see it.
Boom, 100%.
100%. Okay, that's what I
Number
have.
3 is skewed right.
Skewed right.
Literally just put normal for everything and you'll do pretty good.
Yeah, that's what I'm getting here.
100%. Okay. Well, hopefully we understand it pretty well.
I think so. I'm maybe gonna go watch some videos or something.
Yeah, I need to go watch some more videos.
I feel like a dartboard might be more accurate than how I'm figuring stuff out.
Oh, I'm glad I'm not the only one, Ben.
As long as we work together, we'll be okay.
Yeah. So I think I'm going to set up some time with our TA, and I'm going to go over some of the questions that I missed on the homework quiz. Are you guys doing pretty well on those?
Yeah, I'm
Yeah.
doing fine at least.
I've only one attempted on each of them so far.
Okay.
Hey, for number 6, is that normal also?
Number 6 is normal, yes.
Okay.
The first 6, 5, and 4 are all normal, and 3 should be skewed right.
Okay. Awesome. Well, thank you guys. You can have the rest of your night back. Hopefully you get
That
some
was
good
short
sleep.
and sweet.
Yeah, and I hope our next chapter is not super long.
Yeah, I'm gonna take a look at it tonight just in case.
Yeah, I'm gonna print it out.
Maybe if I have more time to be confused, it'll soak in.
And our exam, when's our exams next week, isn't it?
That's a good
There's
question.
exams? I didn't even know.
I
Yeah,
didn't even know there was an exam. Oh, yep. Unit 1 exam.
January 30th.
Yeah,
Oh,
I can't
good to
wait.
know.
yeah. So I think I'm gonna have to set up some time with our TA so I can make sure I understand all these concepts. And then I think he said, are we gonna have, do we get 1 page of notes? I think I read that somewhere.
Yeah, we do.
I don't know.
Okay, if I put together something awesome, I'll just send it out to the group, and if you guys want to add to it, you can, or whatever you
That would
want
be
to do.
awesome.
Yeah.
I will take some time. I started on it on our first chapter, and then I think I partially did it, but I have to go through our other ones. I have a lot of questions, and I've been emailing the professor, but I want him to set up some of the problems for me. So if I get some good information, I'll forward it on.
That would be amazing. I would appreciate
Yeah.
that.
Yeah. Thanks. Okay. Have a good night. See ya.
Yeah, see you guys.
Bye.
Bye.
Okay, bye.